In section 5.4, we look at half-angle formulas. So I'm going to start with the double angle formula for cosine of 2a. One of them is 1 minus 2 sine squared of a. The other is 2 cosine squared of a minus 1. And what I'm going to do here is solve for sine squared of a. So we have cosine of 2a equals 1 minus 2 sine squared of a. If I swap these two terms from one side to the other, I can bring over the negative 2 sine squared of a to the left-hand side, which becomes positive 2 sine squared of a. And then I can put cosine of 2a on the right-hand side, and it becomes a negative because it's positive here. So we have 1 minus cosine of 2a. And then if I divide both sides by 2, we get cancellation here, and that gives us sine squared of a is equal to 1 minus cosine of 2a divided by 2. And this is often what we refer to as the half-angle identity, and the reason we call it that is because this angle here, angle A, is half of the angle over here, which is 2a. So this is our first half-angle identity. And then we can basically do the same thing here. We can solve for cosine of a. And so I'm going to write this down as 2 cosine squared of a minus 1 equals the cosine of 2a. So I just switched sides there. And then if I add 1 to both sides, that will give us 2 cosine squared of a is equal to 1 plus cosine of 2a. And it is true that I could write cosine of 2a plus 1, but I'm writing it like this on purpose. And then we can divide both sides by 2. And canceling the 2 here, we end up with cosine squared of a is 1 plus the cosine of 2a all divided by 2. And this is our other half-angle formula for cosine. And again, it's called the half-angle formula because the angle here, A, is half of the angle on the other side. So if I write both of those formulas using theta instead of A, you can see that we have sine squared theta is 1 minus cosine of 2 theta divided by 2, and cosine squared theta is 1 plus cosine 2 theta divided by 2. So the important thing to point out here is the similarities between the two formulas, right? So if you know one of these, you should know the other one because the only difference is the plus and minus sign that you see here. Now, you can also write these identities slightly differently. And typically what you will see in textbooks is they will let theta be equal to some angle, we'll call it A, divided by 2. So they substitute a over 2 in for theta. And we'll do this one at a time. So in the first identity, we get sine squared of theta, which is a over 2, is equal to 1 minus cosine of 2 times theta, which again is a over 2 divided by 2. And now the 2's cancel out, and this becomes sine squared of a over 2 equals 1 minus the cosine of a divided by 2. And then you can take a square root of both sides, and that gives us sine of a over 2 equals plus or minus the square root of 1 minus cosine of a divided by 2. And this is an alternative way to express the half-angle formula. And I have to admit, this looks more like a half-angle formula because on the left side, you'll see that you have a divided by 2, which literally means half of angle A. Now, if we do the same thing in the second identity, if we replace theta with a over 2, we can go through the exact same steps, and we will end up with cosine of a over 2 equals plus or minus the square root of 1 plus cosine of a divided by 2. And so these are the alternative forms for the half-angle formulas. Now, a couple of comments. You will notice that we have a plus or a minus in each of these. The plus or minus does not mean both. The plus or minus is dependent on the quadrant. So I'll write that down here. Plus or minus depends on quadrant. So it's one or the other. You have to know what quadrant your angle is in order to be able to use the identity or the formula effectively. So just to summarize, here are the half-angle formulas. We have the formulas in what I like to call their squared format, and then we have them in their square root format. And you can use either one of these. It just depends on the problem. And there is also a half-angle formula for the tangent function. This is not covered in some textbooks, but I wanted to include it here just for reference. Now, you don't really need the half-angle formula for tangent too much, because if you can find the sine of a over 2 and the cosine of a over 2, you can get the tangent by simply dividing sine by cosine. Let's take a look at some examples. In the first example, they tell us the cosine of angle A is 3/5, with angle A being between the angle 270 degrees and 360 degrees. And they want us to find the sine of a over 2, the cosine of a over 2, and the tangent of a over 2. So let's bring in the formulas. Sine of a over 2 equals plus or minus 1 minus cosine of a divided by 2 under the square root. And cosine of a over 2 is plus or minus 1 plus cosine of a over 2 under the square root. So the first thing we need to figure out is whether it's going to be positive or negative. And for that, we need to know, where is a over 2? What quadrant is a over 2 in? Well, they don't tell us that. They tell us that angle A is between 360 and 270. So we can use that to figure out where is a over 2. So if A is in between 270 degrees and 360 degrees, notice that if I divide everything by 2 here, we find out that A over 2 is in between 135 degrees and 180 degrees. And that means that A over 2 belongs to the second quadrant, right? Because if an angle is between 135 and 180, it must be in the second quadrant. Now that's really important, because if a over 2 is in the second quadrant, we know that sine in the second quadrant is positive and cosine in the second quadrant is negative. So I have to figure out what quadrant a over 2 belongs to in order to figure out whether I choose plus or minus on these. Okay, now we should be able to finish it. So now to figure out the sine of a over 2, we know that it is going to be equal to positive square root of 1 minus the cosine of a. So what is the cosine of a? Well, they actually told us that. So that's 3/5, and then all divided by 2. Now, why do I put the plus sign here? I'm emphasizing that I made a choice, right? So if I simplify now, this is the square root of 1 minus 3/5, which is 2/5 divided by 2. 2/5 divided by 2 is 1/5, and the square root of 1/5 is 1 over radical 5. And we can write the answer like this, or you can rationalize and you can say that this is radical 5 over 5. Either way is fine. Now, one little detail here, sometimes students will get confused inside here when we do 2/5 divided by 2. Remember that this is nothing more than 2/5 multiplied by the reciprocal of 2. And 2 is 2 over 1. So when I do the reciprocal, that's going to be 1/2. And that is how I got the 1/5. So just in case you were wondering where the 1/5 came from, that's how I got that. Now to do the cosine of a over 2, we know it's going to be the negative square root of 1 plus the cosine of a. Again, cosine of a is 3/5 divided by 2. This is the negative square root of 1 plus 3/5 is 8/5 divided by 2. And that is the negative square root of 4/5. And that could be simplified to be negative 2 over radical 5. So this is one way to write the answer. Or this is equal to negative 2 radical 5 over 5. That's the other way to express the answer. And once again, just to show the detail here, and I probably should have done this for the last one, but in the beginning, when I said 1 plus 3/5 is 8/5, remember that 1 is 1 over 1, and so all I'm doing here is multiplying the top and bottom by 5. So that gives us 5 over 5 plus 3 over 5, which is 8 over 5. So that's how I got that number. And then 8/5 divided by 2, remember 2 is 2 over 1. And so this is just 8/5 multiplied by 1 over 2. And 2 goes into 8 4 times, and that gives us 4/5. Okay, and that's how I got that number. All right, so, there are some semantics involved with arithmetic, but with practice, you will get better at that. Now, the last thing we need to do is just figure out what is the tangent of a over 2. Well, to get the tangent of a over 2, I just need to remember that tangent is always sine divided by cosine. So I just need the sine of a over 2, which is this value up here, radical 5 over 5, and I'm dividing that by the cosine of a over 2, which is negative 2 radical 5 over 5. And then if we multiply by the reciprocal, you can see that the radical 5s cancel out, and 5 goes into 5 one time here. And do keep in mind that there is still a 1 in the numerator. And so we have 1 over negative 2, which is negative 1/2. In the next example, it's pretty much the same thing. We want to find sine a over 2, cosine a over 2, and tangent of a over 2. And this time they tell us that sine of a is negative 12/13, and a is between 180 and 270. And by the way, that means that angle A is in the third quadrant, right? And so let's bring in the formulas for sine and cosine. And remember, the first thing we need to do is determine whether we're using positive or negative. So you got to be careful here because A is in quadrant 3, but a over 2 is not in quadrant 3. So we need to know where is a over 2. So if angle A is between 180 and 270, we can divide all of these by 2 to figure out that the angle A over 2 is between 90 and 135. And that means that A over 2 belongs to the second quadrant. And this is what we use to determine the plus or minus here. So in the second quadrant, sine is positive and cosine is negative. So again, be deliberate when you choose your plus or minus there. Don't just assume, based upon what you see somewhere else, don't just assume you know what quadrant you're in. Make sure that you are talking about a over 2 and not the angle A. Now from here, we can figure out this by just applying the formulas, but there is one other issue. In the formulas, we need the cosine of A, and they don't tell us the cosine of A this time, so we have to figure that out. So to figure that out, we're going to remember that the angle A is in the third quadrant, so I can draw a picture of some angle A in the third quadrant, like so. And what we know about this angle A is sine of A is negative 12 over 13. But we know that sine is opposite over hypotenuse, so the opposite side will be negative 12. The hypotenuse will be 13. And we can find this missing side by using the Pythagorean theorem. Now again, this is the 5, 12, 13 right triangle. It's a special right triangle that we've seen often. So I will just fill in that the missing side here is 5, and it does need to be negative because we're in the third quadrant. But if you're confused about that, you can use the Pythagorean theorem to solve for this missing side. But once we have that, we now know the cosine of A is the adjacent side divided by the hypotenuse, which is negative 5 over 13. And so let's write that down up above here. Cosine of A is negative 5 over 13. And this is the value that we're going to be plugging into our formulas here. And so now we can compute the sine of A over 2. We know that it is going to be positive square root 1 minus the cosine of A. The cosine of A is negative 5/13. So make sure you put in your double negative there and then divide it by 2. And this is equal to the square root of 1 plus 5/13 divided by 2. Now, how do you add 1 and 5/13? Well, you need to get a common denominator, so we can multiply by 13 over 13, and that gives us 13/13 plus 5/13, which is 18/13. So this becomes the square root of 18/13, all divided by 2, and 18/13 divided by 2, remember, you multiply by the reciprocal, and that is going to give us 9/13. So what we have in the end here is the square root of 9/13. And taking the square root of the numerator and the denominator, we get 3 over radical 13. And if you rationalize the denominator, you can write this as 3 radical 13 over 13. Now again, both of these answers are acceptable. Okay, let's go ahead and calculate the cosine of A over 2 now. And so for the cosine of A over 2, we are picking the negative sign, again, because in the second quadrant, cosine is negative. So we have negative square root of 1 plus the cosine of A. Again, cosine of A is negative 5/13, then divided by 2. And so this is negative square root of 1 minus 5/13 over 2. So remember that 1 was 13/13, and you're subtracting 5/13, so that should be 8/13. And when you divide 8/13 by 2, you get 4/13. And I've already shown the work on how to do that division. And then taking the square root of the numerator and the square root of the denominator, we end up with negative 2 over radical 13. And that, of course, can be rewritten as negative 2 radical 13 over 13. And so that's sine and cosine of A over 2. And then finally, to find the tangent of A over 2, we're going to use sine of A over 2 divided by cosine of A over 2. And this is 3 radical 13 over 13 divided by negative 2 radical 13 over 13. And we are going to multiply by the reciprocal of the denominator. And then you see that most of these things cancel out. And we end up getting 3 divided by negative 2, which is the same as negative 3/2. In the next example, we want to use a half-angle formula to find the exact value of the sine of 15 degrees. And to do this, I'm going to make the realization that 15 degrees is the same as 30 degrees divided by 2. So you see it's appropriate to use a half angle formula where in this case A would be 30, right? Because 30 divided by 2 is 15. So when we apply the formula, we have the sine of 15 degrees is the same as the sine of 30 divided by 2, because 15 is 30 divided by 2. And that means that we have the value 30 in for A. So this is going to be equal to the square root of 1 minus the cosine of 30, all divided by 2. So again, I'm just using the value of A here, which is 30, and I'm plugging that same value of A over here, which is also 30. Now the question is it plus or minus? Well, 15 degrees is in the first quadrant, right? And in the first quadrant, everything is positive. So that's why I chose the positive there. And now to finish this, we just need to fill in the value. So cosine of 30 degrees is radical 3 over 2, and then over 2. And now from here, we have to simplify, and this is the tricky part for some. So 1 minus radical 3 over 2. Remember, 1 is 1 over 1. I could multiply the top and bottom by 2, and that gives us 2 over 2 minus radical 3 over 2, which is 2 minus radical 3 over 2. So that's what the numerator is. And then we have that expression divided by 2. Now remember, 2 is the same as 2 over 1. And so this is 2 minus radical 3 over 2 multiplied by 1/2. And if you multiply straight across, you get 2 minus radical 3 over 4. And that's what goes inside of this radical here. So this is equal to the square root of 2 minus radical 3 over 4. And if you then take the square root of the top and the square root of the bottom, you can rewrite this as the square root of 2 minus radical 3 all over 2. So this is the exact value of the sine of 15 degrees. And for our final example, we are going to prove that sine squared of x over 2 equals tangent of x minus sine of x divided by 2 tangent of x. To do this, I'm actually going to start on the right side. So tangent of x minus sine of x divided by 2 tangent of x. What I can do here is I can replace tangent of x with sine of x over cosine of x. So we have sine of x over cosine of x minus the sine of x, and then divided by 2 times the sine of x over the cosine of x. And now from here, what I can do is multiply the top and bottom of this fraction by cosine of x. And what that does is it cancels the denominators here. So sine over cosine times cosine is sine of x minus, and then we have sine of x times cosine of x. And in the denominator, we have sine over cosine times cosine. These cosines simply cancel out, and we get 2 times the sine of x. Now, it may not seem like we've made any progress, but we have all sines and cosines now, and that is definitely progress. In the numerator, we can factor out a sine of x, and that gives us 1 minus cosine of x. And then we have divided by 2 times the sine of x. And that allows us to cancel the sine of x. And what we end up getting here is 1 minus cosine of x divided by 2. And at this point, we are done, because 1 minus cosine of x divided by 2 is the half angle identity, right? It's sine squared of x over 2. And I'll just bring that in for reference. And so here it is. So the identity officially says, or the formula says, sine squared of theta is 1 minus cosine of 2 theta divided by 2. So notice the relationship here. X is 2 theta, right? So x over 2 would just be theta. So the relationship is that this angle here has to be half as big as this angle. So if the angle I have here is x, this angle has to be x divided by 2. And you can see up above here, that is what we were trying to prove.